Om Sri Guru Basavalingaya Nama. Yesterday we started with few things of ray optics. Now let us go with what is isotropic, well, optical medium first. Let us go for first optical medium, then we will go for isotropic medium. Optical medium. Optical medium. Well, suppose say if we take water, light can pass through pure water. But if you take muddy water, some amount of light can pass through. So any medium through which water can pass, that is called as an optical medium. Like if you take pure glass, water, air, etc. They are called as optical medium. Now in optical medium we have got two types of optical medium. One is isotropic optical medium. It is also called as only isotropic medium also, or isotropic medium. As the name itself is indicating, iso, same, tropic region, optical medium. So if suppose we find that we have got some substance with us, and if you are allowing the ray of light to pass in one direction, pass in other direction, pass in some other direction. In any direction, if you find speed of light to remain same, that type of medium is called as isotropic optical medium or isotropic medium. What? If light travels with the same speed in all directions in a substance, then such a medium is called isotropic optical medium. For this one, the example is well, water we can take, pure glass we can take, and you can also take air. So for this, we'll find that reflect well, speed will be same. Now we got other one, an isotropic medium, or an isotropic medium. What we'll find here, speed of light in one direction will be different from that in the other direction. So this type of substance will be called as anisotropic optical medium. That is, the substance in which light travels with different speeds in different direction will be called as anisotropic optical medium. Now, example for this is quartz is there, then calcite is there, etc. In which you will be finding that speed will be found to be different. Now, let's go for next thing. Well, now say we are looking for reflection. You know, suppose say we take some surface, any object. If we allow a ray of light to fall onto it, we are considering here ray of light to fall on it. Now, assume that it is perpendicular at that point where ray of light is incident. We will find that here some amount of light will be sent back in the same medium from which medium the light is coming. So here, if suppose this surface is a good reflector like plane mirror, then most of the light will be reflected or sent back. And if this is a surface like wall, etc., if you allow light to fall, then least amount means few intensity of light will be sent back into the medium. And this phenomena itself is called as what? Reflection. So here, now, well, what is the phenomena? That when a ray of light traveling through a medium is incident on the surface of another medium, a part of the light is sent back into the same medium, This phenomena is called reflection. Now let us say laws of reflection. Laws of reflection. Here we will find that this ray is called incident ray. It is called reflected ray, and it is called normal, or actually we can draw many normals. One normal, two normal. Normal means perpendicular. One normal, two normal, many normals can be drawn. But this normal is where at the point where light is incident. That's why it is called as normal at the point of incidence. So first law state the same, that incident ray, reflected ray, and normal at the point of incidence, all lie in the same plane, What's the meaning of this is, assume that we got these three things. Suppose say we consider them to be like this. See, this is incident ray, this is normal, and it is a reflected ray. So we cannot find that incident ray is like this, reflected ray will be like this. Always you'll find that how they will be? They will be in the same plane. Incident ray, reflected ray, normal at the point of incidence, all lie in the same plane. Now, second one is this angle is called angle of incidence. This angle is called angle of reflection. It is called angle of incidence, and this is called angle of reflection. Angle of reflection. So second law state that always angle of incidence is equal to angle of reflection. Angle of reflection, we can write this as I is equal to R. Now here this angle is called grazing angle. Say it is theta. It's called grazing. This angle is called viewing angle. Viewing angle. Because when light is incident, so this angle and this angle will be same. So it's called viewing angle. Now, sometimes the question will be like this, that if the angle of incidence on a surface is 30 degrees, what is the value of viewing angle? So, this angle will be equal to 60 degree because this is 30, so this will be 30 and this will be 60 degree. Now, we'll go for next thing. Plane mirror. You know, generally we will be using the plane mirrors to see ourselves when we have disturbed, when we want to go out, etc. Well, now same thing we can show here. Suppose that this is a plane mirror. Well, here what we'll have, a glass will be there. One side of it will be perfectly reflecting or perfectly silvered. Other side will be reflecting one. So here we will be silvering it. From this we can see ourselves. And here when we incident any rays of light, then what it will do? Since here mercury is used, so we'll find that the mercury will be acting like a good reflector, so about 95 to 98% of light will be reflected back. And we can say that a plane surface which will be reflecting most of the light incident on it is called as a plane mirror. Now, some basic things of plane mirror. Suppose say that we are standing in front of it. Say we are standing in front of it at a distance of 20 centimeter. Then what we will find that our image will be seen at the same distance behind the mirror. Behind the mirror, at the same distance, we'll find that our image will be seen. Image will be seen now here. So what we'll be finding that distance at which image is formed will be same as that of the object distance. So in general, if we take this as u, this will be as v, we'll find that u will be equal to v. Then here the image will be laterally inverted. When we look in the mirror, we'll find that our this left hand will appear as right hand there, right hand will appear as left hand. Well, viewing angle is also called as one more name, glancing angle. Glancing angle. Now, so our left hand will appear as right hand will appear as left hand. Then, now, if suppose we are moving towards the mirror, we'll find that say we are moving with a speed of 10 meters per second towards the mirror. Then we'll find that image also will be found to move towards the mirror with the same velocity. So, relative velocity, because the two are moving towards each other, relative velocity of the two things will be how much? It will be double the velocity of this. So, we can write on relative velocity of object and image will be how much? 2 times of velocity of the object. 2 times of velocity of the object. If we look at the velocity of person and mirror, that will be same. It will be 10 meters per second. But when we see the velocity of this person with respect to the image, we'll find that will be equal to 2 times of it, because it is travel that this object will move towards a mirror by 10 meters in 1 second. The image also move by 10 meters in 1 second. So distance will be reduced by 2 times over here. Now, here suppose say we have taken 2 mirrors. Say we have taken 2 mirrors and a person is standing in between them, say. In between them. Now what has been found that we will be having one general formula. What? Suppose say that we got first the 2 mirrors to be adjusted like this, that angle between them is somewhat theta, say. Theta. And say person is standing here. Person is standing here. Then how many images will be seen is given by 360 divided by theta minus 1. If we get this ratio as even number, like if we take 360 by 90, 360 divided by 90, I'll write on here, say if theta is 90 degree, then what will happen? It will become 4. 9 4 ja 36 4. 4 is a even number. What we have to do? We have to subtract 1 from this ratio when this number is appearing as A1. Now, on the other hand, if say 360 by theta comes out to be odd, then no need to subtract here. So this will be the number of images seen. So if 360 divided by theta is even, then we use this formula, and if 360 by theta is odd, then we will be using this formula for calculating how many images are formed. If suppose angle is there, then we'll be having like this. Here say two plane mirrors are parallel to each other and a person stands in between them. Here the mirrors are parallel to each other, so angle between two parallel mirrors will be taken as 0 degree. So now what happened? If you use this formula 360 by 0, it comes out to be how much? Infinity. So you'll be able to see infinite images of the person here when a person stands between two plane parallel mirrors. Now coming to spherical mirror. Spherical mirror. Spherical mirror, what we will find that suppose say we have got a hollow spherical surface, like hollow spherical glass surface is there or metallic surface is there. Now we'll talk generally in terms of glass. Suppose if we take a part of it, then this type of mirror will be called, means its one side is coated so that it should reflect light, to say it is that will be made opaque. Other side is say reflecting, then that type of thing is called as spherical mirror. So what? A part of a spherical, hollow spherical surface, one part is opaque, other part is reflecting, called spherical mirror. Now in this spherical mirror we have got two types of spherical mirrors. One is a concave spherical mirror. Concave spherical mirror, it is mostly called as only concave mirror also, or concave mirror. Concave mirror. Suppose say from this spherical surface we remove this part, say this part is removed, and if suppose we coat the outer side of it so that it should become opaque. It should become opaque. Opaque means it should not reflect light. So opaque. Now such a surface is called as a concave mirror. So here its center of curvature, means center of curvature of the sphere will be here. So here its center of curvature will be where? Here, because this portion is taken out from here. So this is the reflecting surface. The reflecting surface is towards the center of the sphere from which this sphere is cut, means it is a part. So such a thing is called as concave mirror. What? If the reflecting surface of a spherical mirror, reflecting surface of a spherical mirror is towards center of curvature of the sphere of which it is a part, then such a thing is called as concave mirror. On the other hand, say we want to go for convex spherical surface, spherical mirror, convex spherical mirror. It's also called as convex mirror. Convex mirror. Now suppose the same part is taken. Let's see. Suppose the same part is taken here. But if suppose inner surface is made opaque, means silvered, and outer surface is kept for reflection purpose, then now here will be the center of curvature of this particular sphere. So here reflecting surface is on the outer side of the surface which is towards the center of curvature of the sphere, then such a thing is called as convex spherical mirror. Means what? A spherical mirror whose whose outer portion away from center of the curvature is made reflecting, then that type of thing is called as convex spherical mirror. It can also be made like this, that generally we call this as concave surface, this as convex surface. So if the convex surface of a spherical surface is made reflecting, and a concave surface is made opaque, then such a mirror is called as convex mirror. Now here some definitions are there, some points to be remembered. First point is pole. Pole, it is denoted by letter P. P. Suppose we take the midpoint of this one. Here, so this point is the midpoint, and here, so this is the midpoint. Then that point is called as what? The pole. The midpoint of the reflecting surface or spherical mirror is called the pole. And here, this point is called C. C means center of curvature. So second one, center of curvature. Center of curvature. See, this is called center of curvature. The name itself is indicating it's a center of curvature. This is the curvature, curved part. It's a center. Well, as center of curvature. The center of the spherical surface of which the spherical mirror may be concave or convex is a part. The center of the spherical surface of which the spherical mirror is a part is called center of curvature, and it is denoted by letter C. Then third one is radius of curvature. Radius of curvature. We can define this one in two manners. What? If we join a line from here to here, we get one distance. This is nothing but radius. So the distance between pole and center of curvature is called radius of curvature. Is one definition. Otherwise, we can say like this also: the radius of the spherical surface of which the spherical mirror is a part is called radius of curvature. Now, fourth one is principal focus. Principal focus. It is denoted by letter capital F. Capital F. Now, we'll use this diagram for its explanation. Suppose say that we have got two type of mirrors. One is the concave mirror and other is the convex mirror. Say we have got. Now, assume that this is the line passing through P, and say C here, it is say P and this is say C. See, well, here one more thing we have to see, that is principal axis first. Principal axis. Principal axis. This line itself, which is passing through pole and center of curvature, is called principal axis. Means a straight line passing through pole and center of curvature is called principal axis. Now for principal focus, suppose say we allow a number of rays which are parallel to principal axis to incident on the mirror. In this case also, say these rays are made to incident on the mirror, and how they are parallel to the principal axis. Now in this case the rays will be reflected back. In this also reflected, but here they will move towards a point which is in between P and C. Here it appears to move from one point, appears to come from a point on the principal axis in between P and C. Well, what happens here? That say this ray is reflected back like this. The principal axis, what is being found? That all the rays will be found to be passing. This point is called the principal focus. In this case, since the rays cannot go in, but it appears as if it is coming from one point. So for that, we can join first these two lines, these 2 points, and if we extend, you will find that the ray is found to be coming from this point on the principal axis. Here also you will find that the ray will be found to be coming like this. Here also you will find that the ray will be found to be coming in this manner. So on. So here, this point also is called the principal focus. So well, we have to define, well, here in both the cases, a parallel beam of light is made to incident on the spherical mirror parallel to principal axis. After reflection, they are meeting at one point on the principal axis. Here, after reflection, they are finding to be diverging from a point on the principal axis. So, this point where it is found to be diverging and this point where the rays are converging are called principal focus. So, you can say when a parallel beam of light parallel to principal axis is incident on a spherical mirror, after reflection, they converges to a point or appears to diverge from a point on the principal axis. That point is called the principal focus. Now, next one, the focal length. Focal length, it is generally denoted by letter small f. Principal focus is denoted by letter capital F. If we take the distance from pole to the principal focus, then this distance is called the focal length. This distance is called the focal length. So what? The distance between pole and principal focus is called focal length. Now, 7th one is focal plane. Focal plane. Focal plane. Suppose say that we have got this as a concave mirror. We can take also for convex mirror, but assume that we have got here one concave mirror and say this is the principal focus. If we take one plane which is passing through the principal focus and perpendicular to it, this plane is passing through where the principal focus and perpendicular to principal axis. This plane is called as the focal plane. So what? A plane passing through principal focus perpendicular to principal axis. Why it is called a focal plane? It is because when a parallel beam of light parallel to principal axis is incident, they will be converging at a point on the principal axis. If suppose rays of light are not parallel, rays of light are parallel, but they are not parallel to a principal axis, they are tilted like this. In this case, what you will find that after passing through this, they will meet at one point somewhere here, where on the plane. After that, they will go in their initial direction, but they will be meeting at one point. So, if we take rays of light parallel in this manner, then they will meet at some other point on the same plane. So, it means for all type of parallel rays which are not parallel to principal axis, there will be a point on this plane where they will be meeting. So, that is why this plane is called the plane containing different focuses. That's why it is called as focal plane. Now, let's go for sign convention, because without sign convention, we will be able to do the problems and derivations over here. So, well, sign conventions. sign conventions. Now what we'll be doing? Suppose say an object is kept here, then the distance of the object is measured from pole itself. If we want to measure focus, we measure the distance from pole only to focus, not from F to P. We measure the distance from P to F. So means first is this all distances are measured from pole along principal axis, Second point, here what we will do, suppose an object is here, its position we want to find out. Generally we use for measuring the distance of object, well, we represent the distance of object by letter U. So this distance as according to first one is, it should be measured from pole along the principal axis. So when we start measuring the distance, what we will find that object is this side. If we start from here to here, we have to go in this direction. But how the rays are traveling? They are traveling in this direction, means towards left rays of light are traveling. But to measure the distance between object and pole, when we are measuring from pole, we have to go like this. So this distances will be taken as what? Negative. Right? What? If ray is traveling like this and we are measuring in this direction, then we will take the distance as negative. Now over here, say we want to measure principal focus or center of curvature. So what we'll find in this case P is over here. This distance will be radius of curvature. This distance will be focal length. The ray is traveling like this. From P to measure any one of them, how we have to go? We have to go in this direction, in the same direction. So that's why this distance are taken as what? Positive. So here R and F will be taken positive in this case. Now in this case U will be negative. What about focal length and radius of curvature? Same thing. From P, when we want to measure focal length, we have to go like this. Ray is traveling in the opposite direction. That's why this distance should be taken negative. Even center of curvature also should be taken negative. It means for concave mirror, we'll find that R will be negative, F will be negative, as well as U also will be negative. And for convex mirror, R will be positive, F will be positive, object says over here, then U will be negative, because to measure the distance of him from here to here, we have to go from pole to this side in the opposite direction of incident ray. That's why it should be taken negative. Now depending upon where the image is formed, we shall be taking that one. Suppose the image is formed over here, then it is again for to measure the distance of image from pole, we have to go like this. Incident ray is traveling like this, so UV will be negative. If the image is from this side, then to measure the distance, say image is formed here, this will be the image distance, so we will be traveling in the direction of incident ray, then we will be taking that one as positive. Now in this case, say image is formed this side, well, generally it is not formed. Say image is formed this side, then image distance will be negative, but image will be formed where? Between these two things. So I will find that image distance will be positive here in the case of this. So now one general thing what we are getting, distances measured in the direction of incident ray. This one we are talking about incident ray are taken positive, are taken positive. Positive. For this, we have explained. If here it will be positive and distances measured in the opposite direction of incident ray are taken negative, are taken negative. It is second point. Now the third point is that suppose say we have got height of the object here to be something like HOC, height of object. Say its image is formed somewhere over here, assume in this manner. Say image is formed. It will be what? Height of image. Now what we do? We consider principal axis. This distance is perpendicular to principal axis. So we take this height as height of object. Now assume that if a object is tilted like this, then also we measure only this height as a HO. We don't consider tilted height over there. We consider perpendicular heights. So here also, if it is tilted, we consider only perpendicular height. So heights, if are measured above principal axis perpendicular to it, then they are taken as what? They are taken positive. Positive. And these heights are taken as negative. So what? Heights, I should put on here, heights measured above principal axis and perpendicular to it, means principal axis are taken positive, and the heights measured below principal axis and perpendicular to principal axis, perpendicular to it, also you can say principal axis are taken negative, are taken negative. So these are the sign conventions. What? All distances are measured from pole along principal axis. Second, distances measured in the direction of incident ray are taken positive, and distances measured in the opposite direction of the incident ray are taken negative. Third one, heights measured above principal axis and perpendicular to principal axis are taken positive, and heights measured below principal axis and perpendicular to principal axis are taken negative. Now here, one short derivation is there, relation between the principal focus and radius of curvature. Relation between relation between focal length and radius of curvature. Focal length and radius of curvature. This is denoted by letter R. It is denoted by letter small f. Now, assume that we got one concave mirror with us, and this is say pole, it is say principal focus, We'll take little away so that our diagram is clear. Say it is principal focus and it is a center of curvature. It is a center of curvature and there is an object kept here, EB. It is called extended object. Say a ray of light is traveling from this parallel to principal axis. It is, we are assuming a concave mirror. We can show likewise for convex mirror, but we will take up only this. Now, here, if you want to find out normal, normal is any ray or any line passing through center of curvature and the curved surface. Because if we take a sphere, we know that says this is center of curvature. If we draw this line, it will be nothing but a normal here. How? Suppose if we draw a tangent here, angle between radius and tangent is 90 degree. Assume if we draw one more line like this, and draw a tangent, then angle between it will be nothing but radius, and it is tangent at that point. So angle between this will be 90 degree. So if we draw any radius line, all the radius line will be perpendicular or normal at that point where they are incident. Like here, this will be normal at this point. If we take like this, it will be normal here. If we take like this, normal there. So all the radius will be normal at that point. So nothing but a normal line. Normal line. Say this is a BC ray. Angle between this and this is theta. Say. Now after reflection, what will happen? It will pass through principal focus. So we have just now seen after reflection, all the rays will be passing through the principal focus. Now this angle will be how much? Say it is theta. What we will find? This angle and this angle, they are alternate angle. So they will be equal. And here if we consider this, so actually this angle and this angle will be alternate angle. They will be 2 theta. Now what you will find that for paraxial rays, this will be, suppose if we take a bigger mirror, then it will be a perpendicular. Means what? The line PEC will be perpendicular here. If we take triangle C, we'll take here this point as D, say. So if we take triangle, in triangle CDF, CDF, CDA, CDP will take it. CDP, if we take tan theta will be how much? Opposite side by base. So that is DP divided by CP. So let us this as equation 1. If we take the second triangle PFP, FDP, so in triangle FDP, if we take tan of 2 theta, tan of t theta, this is as opposite side by base. So means dp divided by fp. Now since this distance will be small in this case, so what will happen? Angle subtended theta and 2 theta will be small. So here we can consider when angle is small, we have got relation that tan theta equal to theta, and here also when angle is small, we can write tan of 2 theta equal to only 2 theta. So what will happen? This can be written as theta equal to dp divided by cp, and here we can write 2 theta equal to dp divided by fp. Now theta, we will take this one as equation 1, put the value of theta. So we get 2 into dp divided by cp is equal to dp divided by fp. Now dp cancels. We know that distance from here to here is called r, distance from here to here is called as f. So we will be getting the relation what? 2 divided by cp, cp is r. So r is equal to 1 divided by, you can write f, or you are writing it reverse, we get F equal to R divided by 2, or we get on R equal to 2F. So this is the relation between R, radius of curvature, and principal focal length. Today here we stop. Tomorrow we'll continue with other thing. Thank you.